Well, we were shuffling, so. Yeah. What I do like to do is track the ether pad. How could I not have internet?
Okay, I know one. Let's go ahead and start.
Okay. Can you guys hear me? Are you guys awake? All right. Good morning. Hey, yes to hearing me. Good morning, everyone. Just in case you are in the room where we are going to be discussing the trusted execution environment and provisioning. Procedural. Note well, I'm not going to read it to you. Hopefully, it's Tuesday morning. You should know this by now. We follow the IETF policies and procedures. Want to get to the meat of the discussion here. So let's go through the agenda. We're just going to go through the logistics with the chairs. We're going to have David Wheeler come up and give us an update on the architecture. For those of you who are new here, we've been tracking work in the drafts through GitHub. So we've posted the link for where the issues are, but David and Ming will be going through those. After that, it should really be David Thaler, had a successful hackathon. So with a couple of other participants, Hannes being one of them, and a couple of folks from Japan. So he'll be providing a report. After that, we're not going to do, since we have not revved the OTRP draft, I don't think there's really anything to report there. So please continue to review and provide comments. We can track them through the GitHub. If you have access or ask for access there, you could input issues and comments there as well. And then there's a new draft to allow us to carry the OTRP over HTTP, which Dave Thaler has started the draft for that. So he'll go over that. So if we have any remaining time, we can ask to see if there are other items. So any comments or issues with the agenda? Boy, it's kind of hard. Hello over there? Yeah, it's kind of hard to see. Yeah, yeah. Okay, so hearing no comments on the agenda, administrative tasks. So the blue sheets, sorry, I was speaking Spanish this morning, so my accent is a little off. The sheets should be going around. Please make sure you sign them. Stephen Banghart, are you here? So thank you for signing up to be our Jabber Scribe. Jaime, thank you for being one of our note takers. We need a second note taker, please. Anyone? We cannot continue until we get that second note taker, please. And we've got the Etherpad link to make it easier. Yeah, I'm trying to look and see who I can pick.
Everybody's looking down, trying to hide.
Yeah. Ned, can I ask you? Thank you. All right, we have 2 note takers. Boy, I'm going to have to bring chocolate next time and bribe people. Okay, so with that, why don't I?
Note takers privileges. If you ever want to go to the mic, you can cut the queue. Right, so there's your incentive.
Oh, I like that. We'll have to remember. Okay, so with that, let me turn it over to Mr. Wheeler and Ming. Okay, this one is already, it's like weird.
Yeah. There's somebody going to full screen where top is that, but I don't know what the right key is.
The other one, let me do it. This one didn't let me. Okay, we'll figure that out later.
Is there some other presenter expert in the room?
Is Ming on?
Yeah, he's on. Well, he's on.
Ming is on Jabber.
Okay.
So,
Ready?
Yeah.
Okay. So, good morning, everybody. My name's Dave Wheeler. Ming should be on the phone, so he's gonna help me as well. Still can't hear? Do I have to be closer? Okay, I'm gonna take it out of here. How's that? Okay, much better. All right, next slide. So we're going to go through all of the document changes that we made. We're going to follow it through the GitHub issues. So hopefully that will allow you to more easily kind of go back and see some of the things that we've done. And then there's several issues that are still open or between the authors in discussion, and so we're bringing in some detailed discussion here, and hopefully you can help us resolve some of those issues, maybe see things from a slightly different perspective. So we'll go through several of the issues in much more detail than others. For ones that are shorter, we think we've resolved those. And the text is in the draft. If you think there's still a problem, we'd love for you to just open an issue on GitHub, and that's the way that we're tracking it, and that's the way that we're resolving it. So any questions or things that you have, even on issues that we've closed, we'd still invite you to open up a new issue and say, hey, I don't think this is quite right, or there's something else that needs to be addressed. Okay, next issue. So here's the status. I'm not going to go through a lot of these in detail. These are the things that we've closed on GitHub, and they're basically around some terminology discussions around device user, device owner, distribution of the TAs, multiple TEEs, some diagrams, multiple TAMs, and some information about the attestation. We haven't closed the attestation yet. We still think that there's more work to do. We'll talk about that in detail. So the items that are still open, we've got 4 items that we think are ready to close. We're going to talk about those today. Hopefully we can get agreement that 3, 8, 13, and 14 we can close. The others we think are still open. Some of them are issues that we got to talk through. The security domains is one that's at the top of the list. We'll have some detailed discussion this morning about that. Others are more just, we got to get around to making the changes in the document, like trust anchor, fingerprint, and some of the key stuff that's going to change a little bit. We just haven't gotten around to that yet. So, but those are the issues that are open. Okay, next slide. Okay, so what I want to do is kind of talk through the issues that we've closed or are ready to close. And this first one is the trusted app distribution. We've had a lot of discussion about this. In the current spec, we didn't really talk enough about this issue of, well, how do I get apps down onto the platform, and what does that look like? In the document, you can see that there's really 3 parts to an application. There's the application itself, what runs in the rich OS, the rich execution environment, REE. That's that little blue box. And that's kind of the app that we normally think about, right? It's the app that the user would interact with. The TA is the trusted app. That's the thing that runs inside the TEE. So that's typically smaller, usually, than the app itself, but it's running in a different environment. And then the green piece is the metadata. That's personalization information, maybe passwords, keys, URLs, things. Some of those things might be private or very specific to that device or that user. So the concept in the architecture draft is that that might be encrypted, and it might be encrypted with a device unique key so that it becomes private. And that data should be consumed by the TA. So there's technically 5 different ways we could package these 3 elements, right? If we take all the different combinations, what we've shown here is the 3 cases that we think make the most sense. So the first is that you package them all together. So that means that the TAM that's delivering this would have to have the ability to encrypt the metadata with a device unique key, package that all together in one package, and send it down to the device. Case 2 is the app and the TA are bundled together, and the metadata comes maybe at a separate time or in a separate message. The third case is all 3 of them are different. They come at different times in different packages. Now, the other 2 cases would be where the app and the metadata are bundled, or the TA and the metadata are bundled. Now, there's a couple of reasons why we don't think those are as useful. So, and part of this has to do with the way that we believe the applications and the TAs are going to be built, right? Typically, you have an application built, and it's for wide distribution. It's not built for a specific device. And the same with the TA. So, but the metadata is device specific. It may have some common elements, some common configuration elements. However, there's going to be device specific information in that, and it's going to be encrypted with the device specific key. So we believe that's really a separate step that the TAM has to make. So it wouldn't really make sense to bundle the app and the metadata and then leave the TA out, because it's also a wide distribution. If you were going to bundle the metadata and the app together, you might as well throw the TA in there as well. So then you're back at case 1. The TA and the metadata, you can make some arguments that maybe that makes sense. But again, if you're bundling a broad-based application together with the metadata, just throw the client app in there, and you're back at case 1 again. So we think these 3 cases are the ones that make the most sense. If you disagree, love to have a comment now. If you think about it later and you think that there's some reason why we would include other packaging, please put a comment on the GitHub. One of the primary issues that we're working out, and it has impacts to the protocol flow, is how you get that device-specific key to the TAM so that the TAM can encrypt the metadata, or the service provider can encrypt the metadata. And this has impacts to how many back and forth trips that we have to make, what key is it, and so forth. And we're going to talk some more about that as we talk about some of the flows and things like that. But in the current spec, we have this idea that there's going to be an AIK, and that's tied to a security domain. We have some more discussion about that, so I'll kind of leave that here and we'll get back to it later. One of the other things that was open in the last meeting was, how do you handle multiple TEEs versus a single TEE? Is it too complex? And so I put this diagram together. It's in the document. So you can see that there's 2 Teep brokers, and they're each talking to their own TEE. So in the case where you have multiple TEEs, a Teep broker will be sort of that agent on the rich side that will manage the interactions with that TEE. And that's platform specific, right? So in essence, you could have an OS that combines those two Teep brokers into one and talks to both of them. But the idea is that the local app is going to know what Teep broker it needs to talk to get to the TEE of interest. This is no different than finding the right USB driver or some other device on the platform. And the OS will provide mechanisms to deobfuscate those and provide the right pointer. In the simplest case, you have one TEE and one Teep broker. So this is the concept that we have in the document. Okay. So then the other concept that some questions came up, well, what about multiple TAMs? How does this work with the TAM? The client app has an application. It might have multiple TAs that it wants to install. Does it have to go to different TAMs to get those TAs? And that sort of makes sense at one level, but let's kind of take a step back. We added some text in the architecture document to kind of explain this, right? So the TAM is really an access point for service providers into devices. So when a service provider wants to put out an application, right, they create an app, they create their TA, they have some way of generating personalization data. Now they want to reach devices out in the market. Different devices are going to support different TAMs. So if you're wanting to get large public distribution of your app, you're going to push your application and TAs out to multiple TAMs. Maybe Verizon has a TAM, maybe T-Mobile has a TAM, maybe there's an Apple Store TAM and a Samsung TAM and a Google Play Store TAM. Right. So you'll push your app and all the TAs that your app needs will get pushed to the TAM. So in a normal case, when a client goes to install that, they only need to go to one TAM. Because as the service provider, you want your application to get out there. You're going to enable the TAs to install, or you're going to enable the TAMs to install all those TAs. Now, there may be a case where for some licensing reason or something like that, maybe there's a inherent dependency where a TA is only supplied by some specific TAM and it's not widely accessible. To handle that case, we said, we're not going to handle that in the general protocol. It can be handled in a couple of ways. One way is that the Teep broker could use the manifest to identify what TAM to go to. That's how normally the Teep broker and the Teep agent are going to work. Another possibility, the last bullet on the slide, is that you go to one TAM and the TAM gets the request for all the TAs. When it doesn't have one of those TAs, it does its own processing to go out and grab that from another TA and provide it down. So then the Teep broker is still only going to a single TAM. And that's the concept that we have. Are there any questions on that? Any disagreements?
Clarifying question for you. Clarifying question, this is Dave Thaler. This is talking about, I'm looking at the bolded point. A client app manifest file can contain all the TAMs you may use to get TAs, normally just one. And you're talking about the client app manifest file. And back on the trusted app distribution slide, we had case 1, case 2, and case 3, trying to figure out where is the client app manifest file? Is that part of the client app? In other words, is this slide focusing on case 3 only,
No.
or what? That's my clarifying question.
Okay. So that's a really good question. And I'm not sure that this concept is fully in the spec. So I'd appreciate some comments back.
Yeah, so Ming is also in the queue. So when you're done, I'll let him speak.
Okay. So the concept is that the client app is going to hold a manifest that was generated by the service provider who created the application. And that will include all the TAMs that the service provider has pushed the app out to. So those TAMs, that list of TAMs then is what the device looks at. It looks at its trust anchor list, says which TAMs do I trust? And obviously there should be some interaction there. There should be some intersection. You select a TAM, you go out to that TAM and get it. So the manifest is supposed to provide you the information of what TAMs have all of these elements, where to get it, and its public key. And so that's how that's supposed to work.
Yeah. Okay, let's let Ming go.
Hi.
Okay, Ming.
We hear you.
We hear
Okay. Okay. Thank you. Hi, everybody. So I think the this struggling point for this one was the how popular the one client app may depend on the multiple third-party trust apps, right? Trust apps. I suggest this was one decision point. We felt that it's a very not common that one client app depends on many third-party TS. Most of the time, common case is client app service provider develops TS themselves. For that case, they can use case one, like bundle case 1 or 2 or 3. And the difficult part is if for the case 3, right, as David Thaler mentioned, that for case 3 where client apps normally app store and TS, if some app, say gaming app, use authentication TA, use a payment TA from different vendors, then what we choose is for this service provider, gaming app service provider, to acquire those binaries from third-party TS and upload to the TAM on its choice. It's maybe one, maybe multiple TAMs, but that's more fulfill versus this sense, right? But that TAM, because we said single TAM, that means if one client app depends on 3 TS, one its own developed, 2 are sourced from a third party it purchase. Then you still need to supply all 3 TA to the TAM that SP choose. As I would assume this is achievable, right? That's this choice we made. This is a contrast to the alternative approach you mentioned, that a manifest file can have 3 TS there, and for each TA, it indicates the time it can go to get installed. So in this case, Teep broker will do the orchestration. It will talk with respect time to get that TA in the client side, versus server side that the primary time will go to the next time to get a TA. I think that's the decision point, and we choose to use the first one. We assume the common case SP owns the TA most time. So I just mention this, clarify this, and get any inputs and feedback.
Okay. Jabber Scribe, you want to relay something?
Yep, this is channeling Hank Burkholtz, who mentions a NIT on Jabber. Trusted App and Trust Anchor both use the acronym TA. He mentions that it's not necessarily really bad, but it was confusing until he remembered exactly what you meant.
Okay. Here it's always trusted application on all of these slides, yeah. So if I understand the answer, when it says, because the relationship between the term manifest and the term package in their slide was kind of my clarifying question, what's the relationship? And as I understand the answer, if you go back 2 slides, I'm going to try to summarize what I think I heard as the answer to my question. I think what I heard is it says, my original question was, is this talking about when it goes and gets what the client app installer does? And I think the answer was no, this is what the bundle composer does. Whoever creates the bundle. And so in case 1, the TAM is creating the bundle in case 1. And I think Ming and you were trying to describe that the way that the TAM creates the bundle is it may go and fetch all the TAs, compose the bundle, and then send the bundle down. Okay. So the fact that there's a manifest, okay, now you can go back to the slide that David was on. So when it says that it can contain or whatever, this is what the TAM is doing to construct the bundle and not what the consumer of the bundle does. Okay, that's I think what you're saying is the answer to my question. This is not something that the agent has any visibility into. This is something the TAM does when constructing the bundle by going and fetching TAs from other TAMs.
TAM
That's what I
SP
understand
has
as
bundle. I would say it's a SP, right? Service provider who supplies
Sorry, sorry.
app.
Right, service provider.
Manifest file, it will contain one or in TAMs that can go to get all those TAs. So we assume SP is responsible to collect all the TA binary into a bundle or supply all TAs into TAM or choice. It's really the case 1 and case 3.
Okay, yeah, I understand.
Okay.
Yeah, so maybe to
Hold on.
Yeah, it was just one smaller issue, but we used the term manifest in 2 different places. One is sort of the manifest for describing the trusted application and potentially where to get it and so on. The other manifest is sort of more from the app development context, where we also have a manifest, so that may be a little confusing. Or did you use it differently?
Okay, so from my view, I think I'm closer aligned to what you said, Dave.
I'm summarizing what I heard from you and Nick.
So the service provider creates an application with 1 or more TAs and creates a manifest that says, here's all the TAMs that I push my application out to, and here's all the TAs that are needed with this. So it provides everything that the Teep needs to go get and install those pieces. So the service provider creates that. That gets pushed out. Now, we haven't really talked about exactly where that manifest is. We've talked about that it's part of the client app, and the client app, if it was pulled down from a store, and then it would interact with the Teep broker and say, here's my manifest, I need you to install the rest of this. There's this concept that we've also talked about where there's an installer, and somehow that installer gets the manifest. We haven't really talked about that T0 time. Where do you get that manifest? Where does the installer get that manifest?
Right, but if you have to go and fetch the TA binary from somebody else, you're by definition in case 3.
Yes.
Right?
Yes.
What that was my question. Is we're only talking about case 3, and your answer was no. In fact, if you don't have to fetch it at all, it's bundled in there. This is something that the bundle composer does when putting it in there, and then
Yes.
the manifest doesn't have to include any separate location to go and fetch it from. It's already part of the bundle.
Correct.
So we will have to figure out like whether we are actually talking what the manifest actually is.
Yeah, I think we need some discussion on that.
Right, that has not been well spaced out for the manifest. I think it is now we talk about the installer. So what is the installer? What are the requirements there? I think that still need working on. And we have in high level we'll have a manifest file that can contain this information.
Okay, so I think the working group does have an opinion, and I think we should one of us should put in the GitHub as an issue to make those clarifications.
I guess the question to David is: do you think this is part of the same issue? Or do you think it's a new issue?
I think it's a new issue.
Yeah.
Okay. Note taker, if you can just take an action item to file a GitHub issue on manifest.
Yeah, so this issue is really, does a client app have to understand multiple TAMs in order to install the TAs? And the answer is no. But I think we have this open question on the format of the manifest. Okay. Okay, so I think we're ready for the next slide.
Sorry.
That's okay. Okay, so one of the open items was, is there only one TA in an application, or can I get into a situation where one TA depends on another TA, and then how complex do we allow this? How deep is that dependency? Can I get into circular dependencies? What happens when I have different client applications that are dependent on different versions of the same TA at the nth level of dependency. So we didn't resolve that. And there's been a couple of recommendations pushed around. And the recommendation that Ming has been asking for is that we defer this until later. I think that there's my perspective is that I think we should find some way of simplifying the dependencies so that we can provide some simple dependencies, or we offload this in some other way. I don't think that I know from the Intel SGX perspective, if you require only a single TA, it's going to really limit the capabilities of Teep to interact with the SGX environment.
Dave Waltimar, just a quick clarifying question. What do you mean by dependency specifically here?
So I'll give you an example. So let's say I have an application that wants to do authentication. So it has a TA that does authentication. And that TA needs an identity key. So then it depends on another TA that provides a key store, a secure key store. So now I have a direct dependency from my client app to the authentication TA, and the authentication TA depends on a key store TA. So that's a simple dependency that happens quite a bit in some environments.
So it sounds like this question's really both about, should we deal with these kinds of dependencies, and then how would we represent the nature of the dependency?
Yes.
Okay, I'm going to let Ming, he's in the queue also, respond.
I'm in Q2 after.
Yes. Okay, Ming, you're on.
Okay, thank you. Okay, so I don't know how to turn on the video because you do not see me, right?
Right.
Yeah, I don't know how to turn on the video. Okay, I will just speak. Okay, so I think in the matter says that follow up the question last in the microphone, right? The simple case is one app can depend on multiple TS, and then manifest file, like we talked earlier. So manifest can list all TS and install them in sequence. But I think that here it depends more about the order, right? Shall we install TA first before TA2? If a client app make that in right order, it's simple case, then it's already we covered today. And here to talk about more the deep dependency. T1 depend TA2 depend TA3, and so on. That must be in that order strictly carried out. Otherwise, right? So if a client app knows that order, then they can put in my file, use that order today. It's a kind of implicitly supported. But I think here we talk about a more complex case. That's where I'm thinking whether we can defer those complex case where client app cannot know the order itself. And it has later TA figure out. So when it runs, I need another TA. The TA includes that dependency itself. So if we can move that up all to client app level, then that's a common case. Right? TA depend on other TS. They handle the installing dependencies. That's where the complexity comes in.
Okay. So I'm in queue here. This is Dave Thaler, and here I'm actually speaking as a suit working group chair, just to be clear, neither as an individual participant nor as a Teep working group chair. So I was chatting with Brendan Moran yesterday as a chair of the both Teep and suit working groups, right? We'd like them to be aligned and compatible. So I was chatting with Brendan. Brendan is the author of the suit manifest document, and asked him his opinion of this issue. And I don't think Brendan's in the room right now. And so that's why, as chair, I will relay what feedback. If he is in the room, please come to the mic. Otherwise, I'll summarize what he said. The suit working group is defining a manifest format that's capable of expressing dependencies and discussing ordering of installs and all that kind of thing like that. Okay. Now, the suit working group is also scoped to focus on optimizing for firmware, right? And so Brendan's thought was he would put into his document to say, this focuses on optimizing for firmware, although this suit manifest format might be usable in larger contexts. And if so, if he does that, then he said that it would be fine for Teep to simply punt the work into saying, as long as the suit manifest can deal with it, and the bundle contains the suit manifest, then you don't have to solve it in this particular working group. And so that's basically the summary from Brendan.
Okay, so now let me speak as the Teep chair.
Yeah.
So shouldn't then that mean that Teep should be putting or imposing some requirements to make sure that the suit manifest meets our needs?
I think that's fair. And I see Dave Waltermeyer, my other co-chair, up at the mic. So
I was just going to echo that we would need to do that
Yeah.
to make sure that we're adequately addressing the functions that are needed.
I can tell you, Brendan told me that he believed that the manifest format, the new one, right, is already generic and could be used for just about anything, even though it wasn't designed for it. So he said, in theory, you could use it for passing, videos and dependencies on codecs and stuff. Not that anybody would ever want to do that, but the point is the manifest format he believes is flexible enough to be used for wider purposes, and he saw no reason that it couldn't be used to solve this Teep problem. Even though that's not what he was focusing on, the manifest format itself is generic.
So can I make a suggestion that that draft be made available to the Teep working group, and then perhaps at minimum at the next face-to-face, and if we have an interim, that we have Brandon present it?
That's a good idea.
Yeah.
My co-chair? Okay, Dave's nodding too. Okay.
Yeah, my comment was very much in the same lines. We had discussed two different cases. One where there's the trusted app itself depends on another trusted app, which you elaborated on, but also the other case where actually multiple trusted apps being provided, maybe code directly or as a reference that need to then be installed in sequence, and all of them need to be successfully installed, or that not only describing having the code for it, but also the correct version of those, which of course raises the question of like, how do we actually version and label the names, or having a proper name for the application, so that we can actually fetch the right thing. But that's also something that the suit manifest deals with. That's why my question was earlier, which type of manifest are we actually talking about?
So Dave, do you think, given that we're going to file another GitHub issue on the manifest, do you think we should cover it in that same GitHub issue?
Yeah, I think we probably have two issues. One is the manifest format.
Yeah.
And then the other is the manifest and bundle creation and processing.
Okay, so two different issues then. Okay, just want to make sure it's clear in the notes that that's a second GitHub issue. Okay.
Okay, any other comments on 13?
Actually, the suit manifest discussion, do you still consider it to be a separate issue from number 13, or is that a proposal for how to solve 13?
I think that's the proposal for how to solve 13.
Okay, so then we don't need a new GitHub issue. We'll just use 13 to track that. Okay.
Well, okay, so my suggestion is to elaborate then in issue number 13.
Yeah.
That just to make sure we have it. Yeah.
One way to solve this is don't defer it to a future version, but simply add a reference to the suit manifest and say it's dealt with there. And not try to just go into all the details in here. So it's another way of deferring it to outside this document.
No.
No, we said just the one issue that we've had on the list before. We said for this one, we're just going to use issue number 13 to talk about.
So for the note takers, issue number 13 just needs to be annotated. So the recommendation for number 13 is to not defer, but rather to use the
Reference work in another working group. Yeah.
Okay.
Dave Waltermeyer is suit co-chair. I think this issue should also be updated to provide requirements to suit for anything that isn't currently addressed by the manifest.
Yeah.
I agree with that.
Yeah.
Brendan's opinion was that there wasn't anything that wasn't already addressed, but I agree with your point that should come as a suit working group request, and then they should look at the authors should look at it and say, okay, yes, we believe these requirements are met. Yeah.
Okay, so
Okay.
he never left the queue. So Ming, feel free to interject, but as the Teep chair, I'm going to ask the suit chairs. That's why I'm looking
Yeah,
at
yeah,
both of
looking
you.
at each other.
So is there a do we need to formalize it by me having to say to the suit working group, track our GitHub, especially number 13? Or can you guys just
I
relay
think
that?
we can just relay it.
Okay.
What do you think? Yeah, okay. Suit is meeting tomorrow morning, and so well, it may come up, we'll see, and because the draft in question is being presented tomorrow morning, so.
Yeah, this means I agree that I think we should first want to leverage what the suit manifest can do, and also send out requirements, say whether it really meet our need. Okay, so
So if
we
there-
have maybe we have conduct, yeah, we have both that we'll see. But I think we should review and look at leverage for that.
Okay. So if there are people in this room that have an opinion on what the requirements are, you are welcome to come to the suit working group meeting. It's in the morning slot tomorrow. And Brendan is presenting this particular draft, and if you have comments on it, this would be a good place to move that discussion so that we don't have to continue that part of the discussion in the Teep working group.
Okay, for the purposes of having the notes be accurate, can you give us Brandon's last name again?
Moran, Moran. And it's Brendan with an E. Right, Brendan. So it's draft Moran. Okay.
Okay. Next slide.
R-E-N.
Do we need maybe to have a draft specifying what we need, or we want just to address what they put in there to see they reflect our interests?
So
Sorry, in Freibisch.
no, that's a good clarification. So I think our first step is to define requirements for what the manifest needs, and
Yeah.
we'll pass that to the suit working group so that they can verify that the manifest can do that. I think then we have the next step, which is to say, how do we create the manifest, what information goes into it, and how it gets processed.
Yeah, but do we need a spec for that? Do we need to write a draft?
Can you
or
identify
we
yourself,
expand?
please?
That will
Sorin Freibisch Del.
Your name again?
Sorin Freibisch Del. Sorin Freibisch from Del. Not
So-
Del, no.
So I think what we'll end up with is a new section in the architecture document. We'll try that. If it starts to explode out, we may say we need another document, but my preference is
Yeah.
not to do that unless the chairs disagree.
Well, the question is also how will be the relation with suit if we have our manifest defined in the document, or they will.
We'll refer to the suit manifest.
So just to be clear, the manifest will be defined in suit, so I expect that to be a different draft. And then this draft will reference the suit draft.
That was Brendan's proposal, which seems like
Yeah.
people are.
So that's why I do think it'll be important to have Brendan present to us, and then we can determine that at that point. But for now, I would see them as two separate
So let's move on
drafts.
to the next issue. So
Yeah,
if we come back to this, we'll come back to it when Brendan is here.
Okay,
Yeah.
that sounds great. Okay, so attestation. We added quite a bit of text around attestation to the current architecture draft. I'm not proposing that we close this at this time. I still think there's some work to do. So I want to walk through what we did in the draft. We defined what we believe attestation is, the assumptions around that, and how we need to support both proprietary and standard attestation signatures, because there's TEEs out there that are available today that have proprietary type attestations. So we need to pull those in. And then there's a proposed format for attestation that we put into the draft. I'm not sure that that's 100% there yet, and we're hoping that we can align with the RATS and EAT work that's going on. So that's likely to change quite a bit, but it starts the discussion. So let's go on to the next slide, and I'll talk more about the attestation pieces. So an attestation is a process, right? It's both a protocol and data where one entity presents a series of claims to another. So the presenter of the claims is the attester, and the person that receives the claims and verifies them or checks them is the verifier. And there needs to be sufficient proof that the verifier is satisfied that those claims are true, or enough information so that the verifier can reject the claims. So there's different verifiers, and verifiers have different standards as to what they require to make that proof. And in our case, right, the verifier is the TAM. The TAM needs to make sure that the TEE is trustworthy. So the Teep attestations are going to be based on asymmetric key pairs that are under control of the TEE, and then we need to define create a well-defined claim set that allows us to carry the claims for Teep to the TAM. So again, the primary purpose in orange here, the primary purpose is that the attestation is going to allow the device to prove to the TAM or to a service provider that the TE in the device has certain properties and is secure. Okay. And again, this is in the draft, so I'm just kind of summarizing this.
Yeah, Rich Saul's clarifying. It's not that the claims are true, but rather that the attester believes that the claims are true. Is that correct?
Yeah, that's true. Yeah. Okay, next slide. So in Teep, the attestation is going to be used for multiple things, right? It's going to prove the identity of the device. That's going to be part of the attestation, or prove the identity of the TA, so that TAM or a service provider could authorize the use of keys. That's an example. Prove the identity of the device or TA so that you can prevent masquerading type attacks on a service provider. It can be used for TA to TA to prove identity there to prevent unauthorized interactions between TAs. It can be used to prevent unauthorized devices from installing a TA into a TEE that the TAM or the service provider doesn't approve of. These are just some of the things. They're examples. I think that they're helpful to think through.
Okay, so now I'm going to speak as the chair of RATS, who will meet for the first time as an official working group. And one of my co-chairs is here, who's Ned. So this is effectively a use case that has been, I'll say, somewhat under discussion in the RATS working group. So I think there will be interdependencies that, again, I encourage all of those who are interested, but who are also working on this, to participate in the RATS, because I would hate to see this be very Teep specific when there's overlap.
I totally agree. I think that we're maybe just half a step ahead, and I haven't coordinated enough with Ned outside, so I'll make sure to do that.
But that's okay. So Ned, I'm presuming I'm putting words in your mouth. Don't take that as a note. That you'll agree to this. Yeah. Okay.
Eric Mark, a comment. So it seems like we're down in a bunch of details, and I wouldn't be surprised if we find that we want to be able to make attestations without providing a unique identity down the road. I mean, if I want to run a key store to provide for other applications to run, why do I need to let whoever is providing that be able to track my unique identity that ties back to me as a PI, right?
Right. So I agree with that in principle. I'm struggling with how to associate that with what we're doing in Teep, which is a service provider installing a particular TA into a particular device. So
Well,
in
service provider could be an ISV, right?
yes,
It's not necessarily a network service provider.
correct.
Correct.
Yep.
So yeah, I mean, I don't know. This sounds like it's closer to rats than Teep. So sort of figuring out how to do something here, but not close the door to doing other things in this working group.
It's a good point, and I think that there are attestations that don't create or don't leak information. EPID is one of those. When we're talking about the type of attestation signatures that we've got currently specified as standard attestation signatures, RSA, ECDSA, those themselves become unique identifiers. Even if you're not specifically giving a device identifier, they become unique.
Yeah, because of the key. Yeah,
Yeah.
That's part of the concern, right? So
Yeah, so then you have something like group signatures, right? And EPID is an example of that. There's some DAA type things as well. So I guess my response to you is, please don't let us forget that. Help us to remember. At this point, I'm having a difficulty understanding exactly where to place that.
well, I think my point as a sort of for the working group is don't try to solve that here, but don't prevent someone else from solving it either by hard coding things saying that you can only deal with these keys that are unique per T.
Okay, so EPID and DAA would, in my mind, are going to be part of proprietary attestation formats that we'll accept. So that gives us anonymity.
Okay, so I'm going to stop the conversation there. One, because we need to move on. The second one is you're listing something that's very specific to an implementation, and I'm not sure that this is completely in scope for Teep.
I mean, it's better discussed
So-
in the grads meeting.
Yeah.
Okay.
Okay, this is Stephen Bankhart channeling Hank Burkholtz over Jabber. He mentions the draft text does not explicitly highlight that TAM and or service provider are taking on the role of verifier. I had problems realizing that only this presentation made that clear for me. Hank would also like to highlight that the assertion presented that the device or TEE respectively is true has to be spelled out very specifically. And then Hank, and you might need to clarify this a little bit because I'm not sure that I 100% understand either. Says, also highlighting that the assertion presented are thing that the device or TEE respectively, the device, okay. I'm getting clarifying text in real time here. Let's try this again from the top.
I think he's asking the same thing that somebody else asked and you answered before, which was the device. It's the things that the device thinks are true, and that's the claims are. And so,
That sounds
yeah,
right to me. And Hank, yeah, okay, Hank says yes.
yes,
Okay.
So yeah, that was covered.
Okay, so as a use case, that's appropriate, but from the attestations, I would say that belongs in the RATS conversation, not here.
Okay.
So if we can move on, please.
Sure. Next slide.
You got plenty of other slides.
Yeah, we're trying to make sure you get
Great.
them all.
Okay, so one of the things that we call out in the spec is that the cryptographic properties that we get out of the attestation are only part of what a verifier needs to comprehend when they're approving an attestation or approving the claims or accepting them as true. There's a wide variety of assumptions that are included in the attestation implicitly. Things like, how was the attestation key installed in the platform? What were the manufacturer's processes and procedures in doing that? How is a key identified as compromised? What are the steps for a compromise? How does a verifier know whether a key's been compromised? All of these things are processes and things that happen outside of the attestation itself, and the verifier needs to be comfortable with those kinds of assumptions that are built into the device and the key and the attestation. So go read the text. Please give us feedback if you think something's missing or incorrect or not stated well. I'll summarize this as saying, you know, the second to last bullet, right? TAMs and service providers have to be comfortable with the assumptions that are inherently part of the attestations that they accept. And TAMs and service providers are free to say, well, I don't like this manufacturer because I don't trust their processes, right? I don't like the way that they handle keys. I don't like the hardware that's being used to protect these keys, so I'm not going to trust that attestation. That's a security policy decision that isn't based upon the verifiability of the signature itself. So that's built into that, and that's needs to be understood. Okay, next slide. So I put some text in to the architecture spec on what standard signatures should be provided, and I'm not sure how we need to coordinate with CFRG on this.
Yeah, I think the question based on the discussion we're having so far with the relationship with RATS is, should the architecture document focus on the use case and the requirements, but not the details of specifying it and leave that to RATS? If so, then this particular slide might be something that moves out of the architecture spec if that's the case. But certainly the cases like who is the verifier, who is the relying party are all use case things that are perfectly appropriate to keep in there, like in the previous slide. So
okay, great. So we may move this
at least
into
that's what I'm hearing so far.
No,
Is,
yeah.
Great. Okay, so if there's something in here that seems wrong to you, or it will probably eventually be moved to the protocol spec, but we appreciate comments. Next slide. So in order to move things forward and to provide some something to throw rocks at, I put together an attestation structure. In the end, we want to align with EATS and RATS, and hopefully we can do that quickly. But from the concepts that we have in Teep, an attestation structure has to have some sort of header that gives us what type of attestation this is. Is this a proprietary attestation, or is this one of the standard forms? If it's one of the standard forms, what type of signature, and probably some version information. Then we need the claims themselves. What's being claimed, and then we need an attestation signature. And I haven't gone to any further detail really than this, other than to say, you know, within the claims we need particular information. I've had some discussion with others already, and gotten some good feedback that this probably needs some more work. That's wonderful, and any comments are appreciated there. Well, one of the things
So-
that
I'm going to speak as chair of both Teep and RATS. So from the Teep perspective, I think it's appropriate to list them as the requirements from a use case and expectations for Teep. But I think it's also valuable for you to show this in the RATS, because it can feed to the set of requirements.
So unfortunately, I'm not going to be here for RATS this time. I'll be on a
Well,
plane. But
I mean,
could be on
next
a
time.
mailing list or next time. Or
Or
whatever.
yeah.
okay, okay,
This is good.
okay. So let's go to the next slide. So one of the things that I'm trying to do and thinking through is taking something like an SGX attestation, which is on the left, and I've highlighted the elements in red there in that red box that identify what are the elements of an SGX attestation. How do they then map into something maybe a little bit more general? And one of the things that I think is important to note, and the reason why I put this slide in here, is when we look at the SGX attestation, there's really only two hierarchies of things that we have. So we have a CPU, SVN, secure version number that tells us what version of microcode is running basically the TEE. And then you have TEE, or more aptly TA identifying information, which includes the hash of the TA code, the hash of the key that signed the TA code, and then a product ID of the TA, and then a security version number for the TA. So the important thing I think that I wanted to communicate to the working group and others to think about is there's often situations where you update an application, but you're not doing a security update. So if you're on if the latest version is 3.1 and you're on 3.0 or 2.9 maybe, it doesn't matter from a security perspective. It's the security version number that's more important when there's a release that says there's a security vulnerability or security problem, and this is the latest security version. Those are the things that are most important. And so in the SGX world, we've separated those out. Now, there is usually some sort of tracking, right? So you have version numbers of the actual code, and then at some particular point you update the security version number because one of the updates included security code. Then you have new features, minor bug fixes, and then another security version. So that should be important for us to correlate in our identifiers for TAs as well. So there's still quite a bit of work to do, so we're not going to close this out. And you know, those are some of those things. So I think we can move on to the next item. So here's work in progress, and this is where I think we need to have a lot of discussion going on. So we've had discussions back and forth on the security domain. And Ming, I'm not sure, do you want to present these slides here?
He's awake. Yeah, he's coming to you.
Okay, Ming, you're on.
Yeah, hi.
You got his video.
We see you.
Yeah, okay, good. Good. Okay, so sure, I can
Oh, there you go.
okay. Do you see me?
We can see you.
You can still see me, right? Okay. It's a slide, right? So security domain, I think currently it's a consensus. We say why we need a security domain needed is it artificial because the overhead for manage of that one. The currently OTIP protocol has that as a first step to create security domains and manage security domains, and then TS are installed on the security domain. And traditionally, it was inherited from the previous TEs. So that's a current packaging TE does have that. So that has discussed in past. I think I don't need to go over the background. More proposal now says, first proposal was last time said to allow just implicit security domain. That is not always need to be explicit. Currently, it is explicit. We'll make it implicit. That means one security domain can be created silently when a TA is installed, so that we can go to install TA directly without going to install security domain. Well, there was also motion here say whether can just completely eliminate the security domain itself in Teep. Right, it's up to TE decide whether they have that layer, but it's only with dealing with trust applications, only TA. So two questions come in related to security domain. So why is needed? And then for security domain, we have introduced a service provider anonymous attestation key. And for that, there's a security concern, privacy concern. We introduced that. And these two are related. I think we can go to the next slide. I think so can you go to the next slide? No.
Yeah, we're on. It's just slow. to
Okay,
update.
thank you. Then we have the thread of discussion, and then Eddie is on the call not. He's also co-author of the spec. We have discussion in issue tracker. So it's a security domain previously is used to it's a as a security boundary, right? Security boundary. So each server provider will own a security domain, and it has group of TS on the security domain. So if you have multiple with whether we can group them, so they use security domain as well as a layer of a trust boundary for that. But it has side effect here. I think in this slide we say we wouldn't need to manage security domain as that's at the layer. It's become primary entity, right? First class citizen in this spec. So that's the main concern. The secondary is well, because security domain and server provider, we added this anonymous attestation key. AIK for use of a security domain. I think discussion on the next one was, so what if we do not say why we need AIK? Well, I explain AIK today. AIK is you create when you create a security domain and you create a key in a device, a new key pair. That public key is sent back to the TAM, and then I can forward to service provider. So service provider can use that key to encrypt any metadata that I presented earlier that include personalization data, secrets, so on, to a trusted application into device. So we choose not to use TE key itself in a privacy consideration where each service provider can use its own key. But there was a discussion there. So can you go to the next slide? I think that was the next slide. The next one.
Okay, we're on slide 3 of 5, Ming.
Yeah.
Options?
Yeah.
So maybe I'll just summarize this real quick,
Yeah,
and then we can go to the next one. So
Yeah.
the discussion that we've had as authors was trying to understand what the security domain was for, and it boiled down. We had different discussions about, well, it helps with management. You can quickly delete TAs. Some discussion was security domain in some of our minds was, well, it's an isolation mechanism, so certain TAs shared some resources in the TEE or something, or was it purely a key provisioning mechanism that associated a AIK, an anonymous type key with a set of TAs. And as we looked at that, we said, well, there's only a couple of things we can do. We either make it mandatory, and then we have all the exchanges and overheads, or we make it implicit by default so that a new security domain is created for each app. And then if you wanted to group TAs together, you could do that with some optional elements, or we make it optional altogether, and that has implications to what key is used, or we remove the concept altogether. So that's sort of where we were, and we haven't really been able to decide as authors. We've had a lot of discussion around it. So and what we've come to at this point was the discussion is really around the AIK and the usage for that, and that seems to be what we've come to, from my opinion.
Yeah, that's the next slide. So you get
Ming, this is Hannes. At the minimum, we have to outline clearly what the features are, and I think you bring up a new point on the anonymous attestation key, namely the interaction with the service provider, which actually isn't documented there. When I looked through this and tried to reverse engineer the properties from the OTRP protocol, there was also another component which was because this AIK was
Yeah.
provided to the client application for then interaction between the client application and the DE, which I didn't see a need for either. You didn't mention that, but instead you mentioned the new one, namely this sort of key provisioning all the way to the service provider, which we don't have in sort of like the currently the protocol runs between the DE and then potentially broker via the broker to the TAM and not all the way to the backend.
So let's
Yeah,
go through until we get to slide 5 of 5, because I think some of these Ming will already be talking about.
Okay,
And so let's let Ming finish the next 2 slides and then
Yeah.
continue this.
Hey, you went 3 of 5 to 4 of 6.
Yeah.
What happened to the math there?
That is have a merge some page. Yeah, now have the straight.
Okay, I'm gonna say it's 4 of 5.
Okay, so this one, so I think this talk about the so the AIK, so where actually needed, because we talk about the 2 use cases AIK is used, right? One is used to encrypt the personalization data and the TA binary itself, right? So just to kind of suggest that one, you get encryption of the binary itself, so it happened by can be by SP, right? They just encrypt it and give it to the TAM, right? And you respond where that interaction part, right? But leave it out of there. Say David Wheeler mentioned this one. So why not a single AIK? Do we need one AIK per SP? And we argument is we feel like actually this is not really strong need for that one. Because it is really encrypt data and send to device. One key from device should be sufficient for the encryption purpose, confidentiality, right? So whether which SP or time sent, that is already in the protocol. So for that purpose, separate AIK per SP is not needed. The next comes down to say whether this AIK, a separate key is needed at all, right? Significant at all. So that's a good second point, because that keys today, giving it back to the TE client app, the rich client app in a rich world, it can query what TAs are installed in the device without contacting TAM, because now it's a local and in offline mode. Offline mode, you don't have the network connect to talk with TAM, but you know what TA is available. But how do you trust that response from TE? And for that case, it return response. That response can be verified by a public key of this local attestation key. For that purpose, then we raise the arguments whether this also required. This argument, I think I believe David Thaler comment here. He mentions that this already device IDs, right? In a device, hardware device ID, MAC address, so on. And say the IE rich OS can hide it. So I would say, well, first one, so I have central questions whether there's a question below, so whether TE certificates, right? TE certificate or TE key certificate should be accessible and exposed to any client apps that can allow to talk with TE. So we can imagine that someone distribute a client app in a form and the user download it and into many devices, then that client app collect device certificates for all devices it goes. So is that a privacy concern or not? So if we consider this a privacy concern there, we better want to, we want TE response to control that instead of relying on the rich OS to do that job, because that will put the burden on rich OS. We don't know we can have that. So
Ming,
yeah.
There were some things I put in the notes in this particular slide.
Okay.
And I think that the first piece that we need to discuss is the AIK, a public key, the appropriate cryptographic operation to use for personalization data. And I gave a bunch of details in the notes in the slides, comparing what I have to do to encrypt personalization data from the service provider to the TEE using the TEE's public key. And there's quite a bit of things that have to be done to create confidentiality, integrity, and proof of source, and and proof of delivery. It's much easier with the symmetric key. And if we have a symmetric key, we don't have any privacy concerns because it's generated automatically. So I really think that we need to in my opinion, I think we need to dispose of the AIK for personalization protection and use a symmetric key. And then all of this then goes away. And then I think we end up in the case where the security domain becomes either optional or it becomes removed. And that's my opinion.
Yeah. Next slide. Yeah.
Slide 5 of 5.
Well, yeah. So Maine, can we move now to slide 5 of 5?
Yes.
Okay. We're there.
Okay. So, so now this was that. So we look at separate AIK. That looks not that necessary, right? Necessary. So TE key, well, it's a TE public key. TE has that certificate of public key can be used for that key wrapping. Right? Today, personalization data encrypted use separate public key. Well, not encrypted. Well, use a symmetric key. As David point, actually, we already assume this random secret symmetric data encrypted key is used, but that is wrapped by the public key, right? Transport key as a transport key to the device. So now it's whether we just, if we eliminate secret domain, if we eliminate that one, then this is not needed. Then we can just use that TE public key to transport that symmetric key because only that device can decrypt it. So the motion here was okay. It doesn't look secret domain in this is fully needed, right? Fully needed. So the only concern was existing TE, and we know that the existing TEs there, they have been using secret domain. So if we say Teep do not support it, right? Teep do not support it. We just direct go TA, and then TE vendors implementation, they will need to choose how to link to that, right? How to support secret domain how to support TS within their current structure or their major change. And then for T perspective, as we argue, we do not have a compelling requirement to feel we have to introduce secret domain for this. That was more for traditional reasons in a way.
Yeah. This Hannes. Yeah, I like the idea to explore the use of symmetric keys instead of this AIK. I think that's something we should look into, specifically if the service provider creates this metadata and encrypts it. It most likely will also encrypt the DA binary with a symmetric key. So maybe there's some reuse effect there, and also having sort of the security domain concept implicit or completely optional will then allow us to reduce a round trip for the creation, which otherwise would always be there if you create a new security domain, which I suspect that in many cases you wouldn't want, or these isolation concepts would be there anyway, regardless of on the secure world side between the different DAs, and they would have to define well-designed interfaces to talk to each other anyway. So I don't think we are losing much, but I believe that's a starting point for some more detailed investigations.
So more specifically, if we made the security domain implicit, and so anything that was installed from the same service provider public key would go into the same security domain.
Yeah.
And a service provider that didn't want to do that would use a different public key.
Yeah.
Would that be acceptable?
Yeah,
Yeah, that's one way. I think, yeah, that's one way they could do that as a default behavior. Right, today is explicit, right? SP may owns multiple security domain, right? So now say for one security domain well, if they want to do, they can use a public key as a kind of identifier to as trigger of this different SD.
Okay. Dave Taylor, individual participant. Before I say what I was going to say, I couldn't tell if Hannes, you were arguing for or against the recommendation on this slide. My guess is you were okay. Remove security domain from the protocol. Maybe you had to have informational text that says what an implementation might do, but it wouldn't show up in the protocol as a normative thing. I couldn't tell if that's what you were actually suggesting. So
That was the clarification I had.
So in my opinion, so if you make the security domain implicit, it basically gets removed from the protocol as a feature. We
Okay.
can still do an optimization.
Here's the options on the slide.
Okay.
Mandatory, implicit, optional, and remove.
And Hannes was going for option number 2, and the clarification I had in the slide 5 of 5
which one's the
was
recommendation?
it wasn't clear to me of these 4 options which one the recommendation was going towards, because it just said remove security domain.
Right,
That's
and
four.
we couldn't
That's
agree.
four.
Number 4.
Right,
Number
so
four.
number 4 was my recommendation, was remove it.
Okay.
Um,
And Hannes is saying,
Well, Dave made a new sort of proposal which is not captured in 2. So for me, it would be implicit, and then an extension could make this optimization happen. So by additionally creating this security domain, but here it also then says using the default blah blah, provisioning a public key, and the proposal that Dave mentioned earlier was, let's explore how we would actually use a symmetric key for the AIK to protect the data that is then encrypted, like the metadata and also the DA binary. I
Yeah.
think that makes a lot of sense to me, because you will want to have that anyway, because like you
Right.
encrypt data with a symmetric key.
right, so
I was on the we use 2. I would more prefer to more be cautious side. Yes, I know it may, if you don't have a way to allow, right, you have make it implicit, have that separate key for that possibility, and then it doesn't break some existing TE right away, right? At least they can have a forward-looking pass. That was my thinking.
Okay. Dave Taylor, back to the mic as individual participant. I understand, David Wheeler, you're arguing for option number 4. As an individual participant and hackathon implementer, I have no objection to number 4. I think you guys are debating between 2 and 4,
Right.
and that's why I would also be fine with saying there's nothing normative about security domain anywhere in any document, but there might be informational text that says, oh, by the way, if you happen to have an implementation, here's what you might do in the implementation, in which case number 2 is kind of there in informative text, but nothing normative. That's kind of what I thought Hannes was arguing for, and if so, I have no objection to that either. On number 2, what I was going to comment on is I think some of the arguments around AIK or whatever in the discussion of having some security association that goes between the service provider and the TEE to which the TAM is not privy to those keys is kind of an interesting discussion. And the for at least the use cases that I have, it is the case where the TA, not the TE, but the TA would want to have its own key pair. Like the TA wants to do an attest to some other, TA on a different device and so on. And so you have one key pair for the TEE itself, or the device, and one for the TA. And I didn't see a reason or a need to have an additional one for the SD that's kind of neither of those two could solve. Like any use case I can think of, I can solve by using one key or the other key. So you might imagine the TA key is used to generate a symmetric key between the service provider and the TA that other TAs don't have, even other TAs inside the same security domain if there were any. Okay, and so I can figure out how to solve all those with these 2 other keys. And that's why I think I would be fine if there was no security domain in the document. But if you want to say, oh, and for things that have this notion of security domain, here's what it means for them is you might do X, and you might do Y, or whatever, there's nothing normative. That would be my preference right now as an individual implementer.
And Hannes, I think 4 would be okay for me as well, because we, in any case, have to describe on what the keys, the symmetric keys that we are establishing to protect that information, with whom they relate with, what the key naming is. And in some sense, even though the name security domain doesn't show up anymore, we'll have some text there. So it would be, I think, a more or less confusing substitute than there, because the security domain concept has been extremely confusing in all the discussions.
Yeah, I think it's fine if there's example text that says, okay, you know, like in an SGX context, you have no OS and here's what it means. And like your slide on SGX attestation, you might say, by way of example, if this was SGX, it might look like the following, or there's only one level. By the way, if you're in a trust zone context and you're running OPT, then here's an example or something like that. By the way, if you're running in a global platform context, here's what it means in a global platform context or whatever. So I have no problem with informative text, but as an individual, I kind of like number 4, at least for normative text. Okay. So anyway, end of my individual participant comments.
Ming's trying to talk.
Ming, we lost you. He's on the.
We see you, but we don't hear you.
We
Can't
don't
hear
hear
me?
you, Ming.
Can you hear me?
Now we hear you.
Okay. Okay. So I think comment on the symmetric key part. We thought about that in one point. Just I get a clarification from David and Hannes that what do you mean there? When you use a separate asymmetric key, it can be permanent. If you use symmetric key, it's more like a one-time session key, right? We use data encryption, but if you maintain that permanent, then now you have a key in per TA or per device. Now at time SP need to record that for all devices, permanent record. Remember that symmetric key. I think that exposes some security challenge. But instead, you have an ARK or one ARK, right? You don't have many, like, well, and David argued for one key per TA. For that, only that TA can decrypt data, right? That was the motivation of the ARK earlier. Instead of one per TA, we have one per group of TAs, right? That means one per service provider. Their TAs can receive data only sent to them. All the other TAs cannot decrypt data, right? So that was the purpose where different TAs can get the key only wrapped to them, transport to them. So that transport key is used. So and only public key is given to the SP on time instead of symmetric key. So and the symmetric key is still it's data encryption key. It's always generated in a data exchange, right? When encryption, symmetric key is used to encrypt, but symmetric key is further wrapped by this public key, so that only that can decrypt. So I just give the comments on the symmetric key versus ARK choice we made earlier. So now,
Okay, I did hear, and I think we're just circling back. So I want to close on this particular issue. So I want to make sure what I heard from Hannes and from Dave as an individual contributor, they're fine with the recommendation and the use of symmetric keys. So I just want to get a sense from the room, are there any objections to go with the recommendation as listed? Going once? Going twice? Anybody awake? Okay, so let's just resolve the issue per the recommendation so that we can close it and move on.
Okay,
Okay?
great.
All right, can we move on to the next one? We're going to move on to the next one. Number 18, trust anchor update.
Okay, so the trust anchor, there's been some minor confusion, I think, back and forth about how do we do management of the trust anchors, how are trust anchors installed, and some of us feel, you know, that might be better in a separate document. We really need to focus on just the requirements of how trust anchors are used and what their properties and requirements are inside Teep. I don't think we need to go through all of the manufacturing of trust anchors and all the provisioning. It's much more important to do that. And what we talked about was aligning with the suit definition of what a trust anchor is and the requirements on a trust anchor store. Dave Thaler forwarded some of my requirement changes to suit in regards to the store. So I think that's how we're going to resolve that one.
Good. No comments?
Okay, good.
Let's move on.
Okay, there was a question about installing a TA in a single pass. I think let's defer this discussion to the hackathon because Dave Thaler has more input there.
So we need to give him time.
We need to give him time. And the local TE signing first. So there was a proposal about making the TE Connect sort of go away. There's this concept, I think Dave's going to talk about this a bit in the hackathon as well, where there's a null request to talk to the TAM, and then the TAM says, please tell me your device status, and then we tell the device status.
Okay, I'm going to, sorry.
So the one point that I want to make is there's been lots of discussion back and forth. My comments here is the objection was that if you send your signed attestation to a TAM, then you might be revealing identity information through your key. The discussion here is that no, you don't have to do that. You can make some decisions locally in Teep based upon your manifest and the TAM key to make sure that that's within your trust anchor. So I think we can resolve that. I'm for saying, install TA is the message. I think we'll have some more discussion on that.
Yeah, and Ming's on the queue, so. Ming, you're back on.
And I'm okay now. I was for earlier I just said that the first slides, yeah, that can go to the
Okay. So let's move on
Yeah.
since Dave will speak to it in the hackathon. Okay. Yeah, are you
Channeling Hank Burkholz on Jabber.
okay?
Hank mentions that there is ongoing work on trust anchors in Yang and that we should be sure to have a dialogue there.
I think you said the NetConf working group has an ongoing discussion on trust anchors in Yang. So they're being NetConf. Yeah, thank you.
Okay. Next one. Oh. You're in on the queue, then we're moving to the next one.
Hi there, real quick, Eric Voigt, Cisco. Basically, it's not the NetConf working group. The people in the NetConf working group, such as I and others, have helped with a Yang model that actually is in the RETS working group.
Oh.
Or will be.
Yes.
Will be. Thank you. Okay. Issue number 12.
Issue number 12 was, does every rich app talk to the TAM? And the response is no, not necessarily. Some of this is maybe imprecise text in how these flows go. We'll clean that up in some of the flows in the future session. In the future drops of the document, but basically there's some piece of code that talks to the TAM. That could be an OS service. It could be something that's part of the OS itself. It could be a library that you link into your application. But in essence, it's something that the client app talks to. So the client app could integrate that and talk directly to the TAM, but it's all just a software decomposition issue. Next slide. That's it.
Oh.
Nice.
Cool.
Well done. And you're kind of on time, which is great. Thank you.
So I think what hackathon report is next, if I remember right.
Yeah.
Okay. Okay.
Now I have to present.
Yeah. So we got a ton of hacking done at the hackathon. Next. These are the participants. The two folks there are from AIST, and they had an implementation that they had done ahead of time of a part of it. They didn't actually bring the boards with them, and so we had a bunch of discussions about what they found in the implementation, but we couldn't actually do interoperability testing for reasons I'll explain in just a minute. Go ahead, next. Okay. Gee, the formatting is weird on this display. That's okay.
You want me
Yeah.
to full screen?
You can try that. I don't think it's going to change. No, it's
Nope.
not. Okay. All right. You can go on to the next slide. Yeah, we talked about all three drafts. We worked on all three drafts. Next. Okay. As a reminder, just to refresh your memory, what was done before this hackathon, what we did last IETF at the hackathon there, is at that point we had the GitHub implementation, because we know of now probably 3 different implementations of OTRP. At 103, Ming had his, and I had mine, and the Japanese folks is the third one, and they were at this hackathon that Ming was not at. So between the two IETFs, we had 2 at each of the hackathons, but altogether we have at least 3 that have been involved in discussions. Okay, so last IETF, we tried to implement, I tried to implement OTRP starting over SGX, had to port open source Jose implementation, and this is where we kind of designed between Ming and I what went into the OTRP over HTTP spec, which hadn't been written at that point. And so based on the discussion that we kind of agreed to and started implementing there, that's what we presented to the working group last IETF. And so this IETF, working on updating that, and so that's what you'll see. So that draft is basically the output from Hackathon 103. So now you can go on to say what we did this time. So before you go on, the last point there, the OTRP spec or no place, it talked about exactly how you do periodic checks for policy. This means a service provider or somebody has policy that needs to be pushed down to the device, maybe updated personalization data, maybe a new version of a TA. And so the client is running perfectly happy, but how does the administrator, the service provider, whatever it is, push down an update to that? And so that's the policy checks that the client would have to somehow connect back to say, I'm happy going along just fine. Anything new for me? And it says, yes, I have new stuff for you. And so we had a discussion about that between Ming and I last IETF. And so we designed it, but did not implement it then. Okay, now you can go on.
Well, I have a question, because you say it's partly covered in the HTTP draft and partly in the OTRP issue.
Yep.
So will the 2 complete what's needed, or do we need to create another? Okay.
The GitHub issue number 2, in GitHub, right, we have issues filed on documents.
Right.
Okay, and so out of the 3 documents, right, this is the issue that is filed against the OTRP protocol document for its part of it. Once issue number 2 is addressed, that means that both documents will correctly cover their pieces of it. So yes,
Okay.
it's just since the OTRP protocol has not been updated, and in order to find the proposal, you have to look at the GitHub issue. Okay, you can move on unless other questions. Okay, this IETF, what we did, what I did for coding and what we collectively did in discussion. So I mentioned there's 2 different implementations represented. Across the 2 implementations that were present, I was working on both SGX and Trust Zone, and the folks from AIST were working on both Trust Zone and RISC-V. Okay, so in other words, everybody at the entire table, including Hannes, was using Trust Zone for something. And so we were all Trust Zone people, but some of us were also SGX people, and some of us were also RISC-V people. So between us, we could have discussions that says, how does this apply to this type of TEE? How does it apply to that type of TEE? So we actually had some good discussions about making sure that things really were agnostic as to type of TEE when we look at what the Teep is doing. So that part was very beneficial. Also, since last IETF, there's an SDK that all of us played with a little bit that tries to support both SGX and Trust Zone so far in terms of an abstraction that you can write code on top of. And so we took the code from last hackathon and ported it to run over here. So that last hackathon, I remember I mentioned it was SGX only for that GitHub. Now the code is actually agnostic. It's supposed to work on SGX and Trust Zone, same OTRP code, okay, for the parts that have been implemented so far. It was updated to match the latest HTTP transport spec, which I'll talk about in the next presentation. And the GitHub issue number 2, that part of OTRP was updated to actually match that. Last time we designed it but didn't implement it. Okay, now it's implemented, at least in my the 3 implementations, it's implemented in mine. Okay, so what we collectively learned between those of us at the table, we had a number of discussions. We filed 5 new draft issues on the OTRP spec. And we added comments on 3 existing issues based on the discussions and proposals that we had here. And so I'm going to walk through those depending on how much time we have, because I want to make sure we have
We have
time to
20
get to
minutes.
Okay, great. So we have time. All right. This is a summary that I presented at the hackathon. I'm going to actually go through these in subsequent slides given we have time. So we can skip the bottom half of this because it's all on subsequent slides. Okay. These are snapshots of the actual GitHub issue. Some of these are pretty trivial, and so if I wanted to skip these, we can. First observation that we had was in the OGRP protocol spec, right? So now we kind of skipped the OGRP protocol discussion. This is it, okay? In the OGRP protocol spec, in the device state response, it has this snippet in the middle of the message. You can see it's reporting this list of security domains, which might become moot according to the previous recommendation. And so I think we should just go on to the next slide.
Yeah, I was like, we don't have to.
Okay. The next one is in that same message, the get device state response, right? This is TEE information, and I know you can't necessarily read the text, but this is so that I can read it and to explain it, right? It has a cert field and a CA cert field, and the cert field contains basically the certificate. That's the leaf certificate in the chain. Okay, so this is like the TEE certificate that chains up to a CA. And the CA cert field is an array that has a list of the certificates that are everything above the leaf back up to the root. Okay, so the entire cert chain is split into 2 fields. There's the leaf in one field and the rest of the chain in the other field. Okay, when doing an OTRP implementation, okay, you have to use JSON web signatures, and the JSON-WS spec has this X5C field that you have to implement, and it's actually mentioned in the OTRP spec itself. The way that X5C is encoded is you have your entire cert chain in one JSON array. So that means, as currently specified, you have to have 2 pieces of code to encode and decode, to construct and to parse cert chains. In the OTRP part, you have to split the cert chain into 2 pieces and encode one in one field and the rest of it in another one. And the X5C field, you have to combine them. That means you have to have 2 gratuitously different pieces of code. And so the issue here is, why are they separate fields instead of doing it the same way as X5C, which you already have to implement in your OTRP code, and just put them all in one array? That's what this issue is tracking. It would be much simpler to just match what JWS does and say there's just a cert array, and which is exactly what JWS does. So that's what this issue is filed. Okay. There's a field in the device state report that has the TEE name, okay? And it's underspecified what that is. So we kind of compared notes. What did you implement? What did you implement for this field? The document has an example which has the literal value primary space TEE in the example. So it wasn't clear to us, and we'd implemented different ways to say, is this something like the string Intel space SGX to say what type it is? Or is this an instance number, like on my machine it's called A, but on your machine it's called B? And so exactly what is the uniqueness characteristics, and the spec doesn't say. And so the AIST folks said, well, they ignored the field on receipt and filled in a dummy value that's hard-coded on sending it, because they couldn't figure it out. And in my code, I had filled in Intel SGX and op-T for the 2 cases, and both of those might be wrong, right? If it's an arbitrary string that the TE gets to fill in, okay? The only case that OTRP talks about it is when you have multiple TEEs, it tells you which one to hand off to, right? And that's not sufficient to answer the question. So it's we all agreed that it was underspecified, and trying to figure out what to do with this in our implementation. And you can see the bottom question is, or should the field be deleted? Okay. Which gets into a little bit of overlap with when we talk about the attestation part, which is, I think, the last of these issues. So
You want me to go?
I want to go on because the should it be deleted is a potentially valid answer. Okay. Right next to the name is this version field, and it has an example value of 1.0. And again, the spec doesn't say what it should contain or who defines the value. And so we couldn't tell among the people at the table whether it was supposed to be a version number of the hardware, such as the CPU SVN on David's slide, or of the TEE software, like what's the version of opt that I'm running, or is it the version number of the OTRP agent, or none of the above? And we couldn't tell. And so similarly, question is, should this field be deleted, which I'll get to, which is one possible resolution. And so it's actually unclear what to do here. So we filed an issue. Don't have a proposal other than maybe it should be deleted. Let's go on. This is the last one. Okay. There's already the issue that David talked about, which is the filing of the how to handle attestation in the architecture document. Okay. The OTRP spec is the protocol spec, which also needs to match. There wasn't previously an issue filed against the protocol spec to say you need to cover attestation or whatever it means in the protocol spec. So we filed this to say, and you can see this is related to architecture issue, right? So it's basically the same issue. Architecture document is the issue number David covered. Here's the equivalent issue to track whatever the changes need to be for the protocol spec, okay? And so here, this kind of summarizes some of the discussion. And so this adds a little bit to the discussion we had before. And so the overall observation I will summarize, which is the get device state response message that's defined in the defined in OTRP spec today, contains a bunch of security information, which is basically the TEE sending information that's signed by the TE off to the TAM for it to make a security decision. That's a lot like an attestation, right? It's sending the claims and the proof for it to decide, okay? And so the question that came up is get device state response, is that duplicating? Is it actually an attestation piece? In which case, it would be an overlap with, say, what RATs might want to be talking about. And does it actually still belong in the OTRP spec, or should this just reference an attestation protocol that's defined elsewhere? That's the overall question. And if that was the case, then if you go down that branch of the discussion, then the get device state message would either be absent if there was a different message in a different protocol, or it would be an encapsulator for some message. In that case, those other fields I mentioned, they would go away because they would be inside this other attestation message. Right now, things like name and version are outside these certificates, but in many of the attestation mechanisms, they would be claims inside the certificate, right? So instead of saying my TE name is whatever, in parallel to me sending the certificate, it would be a certificate extension inside the certificate where it's signed as part of the certificate that's attested. That's just another way to encode the same information, and another way that the name and version fields might be able to be deleted. When we look at, say, how the trusted computing group defines their cert chains, that mechanism would be consistent, saying, no, the name and the version, they would just be fields that's certificate extensions inside the certs, not as parallel fields. There's multiple reasons why the name and version might actually be deletable. Okay. All right. I think that's the end of the hackathon report. Any questions on the OTRP protocol before I go into transport stuff? No. Okay.
Okay.
Coming to Mike. Okay. Go ahead, Min.
It's me. Just want a little bit clarification. First one, good findings. Thank you. There's first two editorial. Then about the TE name and the version, just a motivation there was OTRP protocol. TE name and the versions are kind of claims, kind of attributes about the environment that should be part of attestation. So idea is that when you send TE name and a version number, it's about TE itself, not device. Okay, and TAM can define policy says I will give a trusted application only for those TEs I trust. Right, so that way TE name and version. But now it's coming down say that part where's the truth of that TE name and version. I think that's what you raised, right? We didn't require TE name and version part of TE certificate itself. So you're saying whether that one when you issue TE certificate, that's all part of the information there, or in other part of that. I think that's a good question. But currently there's when TE generates that request device state information, it includes all the information there. That have the environment information sent over. So time will make that decision whether it's continue. So that is for those 2 minutes. That's all.
Yep. Thank you. I think as an implementer, it would be simpler to just let those be inside the certificate and not parallel fields. So,
okay. Thank you.
Go on to transport discussion. Okay. So the transport document was written shortly after last IETF. That was draft 00, and then it was rev to 01 after a review that I'll mention in a slide or two here. But I presented this last IETF. So last IETF, this was slideware because it was designed at the hackathon and then presented like 2 days later or whatever. And so now the first intent of 00 was to match in document form exactly what was on the slides at last IETF. Okay. And so I will show you one slide later on because my point is to talk about what's the deltas since last IETF. Okay. Which is the differences between 0 and 1 really. Okay. All right. As a reminder, if you're new to this discussion, if you missed the discussion last time and you can't remember what we talked about, here's the summary. There's a division of labor in the specs between the OTRP protocol and this document, okay? There is not an intent that this stuff should go into the OTRP spec. Why is that? Well, as the OTRP spec covers the communication between the agent and the TAM, which is things that go from inside the TEE, right? The transport is outside the TEE, okay? Which the architecture document calls the broker, right? And so the OTRP spec is something that the agent can claim compliance to. This spec is one that the broker could claim compliance to. Okay, so there's a division of labor between different components and what they comply to. That's supposed to be a clean layering. Okay. All right. Yeah. So in the architecture document, the terminology there, there was one part that was a little bit confusing, and so I had a different term when I wrote this document here. And you can see in quotes there, I use this term TAM broker. And I wanted to throw that out there because I'm wondering, should the architecture document have this term? It currently doesn't. Okay? And the distinction here is there's actually two different ways to implement a TAM. Okay? One way to implement a TAM is you write a TAM service the way you've always written a TAM service. The other way to write a TAM is to use a TEE. Okay? You're using, say, SGX inside the TAM. And so you have the part of the TAM that does OTRP that's running inside a trusted application in the TAM service. And you have the part that's outside that's implementing, you know, HTTP or whatever. Okay? And so in that case, you have these two pieces, and which you'll see in a later slide, which actually showed up at IETF 103, but it didn't have these terms on it. It just said HTTP server and TAM. And so I've changed that to say the part that's the HTTP server implements this spec, and I needed a name for that, and so I called that TAM broker, which is the TAM side of the transport. Okay. And so if you're using a TEE, this would be the part that's outside the TEE on the TAM side. If you're not, then this is just the transport part that complies with the spec that's in the TAM. David has comments.
So if I understand what you're saying,
Name?
Dave Wheeler.
Yeah, thank you.
So if I understand what you're saying, in the architecture spec, you'd like us to not say TEE, but say Teep agent.
Today, when it says TEE, it always uses TEE to mean the TEE on the device, okay? Whereas the TAM could have a trusted execution environment too, so that term was a little bit confusing because when you have one in the TAM, there is a TEE up here, but when the document says TEE, it never talks about that one. It means the other one down here on the device, right?
But I think what might be clearer, right, is to in the definition say we have a Teep agent,
Yeah.
which is in the
the
device's
device.
TEE,
Yep.
and we have a Teep broker, which is
Yeah, that one.
right.
Well, that's one of them.
Yeah,
yes,
so maybe we need to
See,
add the
this
Teep.
blows up the device, but doesn't blow up the TAM. Yeah.
Right. So
Yeah.
if we blow that up and then inside the TEEs we have the Teep broker talking to
Yeah.
the Teep agent.
So
Right.
I'll show you my message flow and you can see what the labels are and how to match that. But again, I'm trying to write this document in a way that's agnostic as to whether you have a TEE in the TAM or not, okay? Meaning it should cover both cases, right? But
Right.
it could, and certainly in my implementation, it does.
I think that makes sense.
Yeah.
So
So
let's coordinate.
It's
afterwards.
fine to have multiple figures
Yeah,
where,
yeah,
you know,
yeah.
you've got the abstract
yeah.
for how the device speaks outside, but then inside the TEE, you've got intercommunication. So
Yeah.
we kind of had that discussion of having two different blowups.
Okay.
Yeah.
Okay.
Eric?
Eric, not Mark. Yeah, but aren't we mostly concerned about the protocol? And sure, you might be reusing some ORTP thing over there, or it might be quantum computer or whatever, but from the perspective of what we're describing, it's a service called a TAM. Microservices, quantum computer, load balancers, why do we care? I mean, if you want to write a separate spec says, here's an informational document of how I built my TAM, that's fine with me. But confusing this stuff, saying, oh, there's two TEs, and which one am I talking about? I think that's just making it more confusing.
I I think it's necessary to talk about, at least in the security considerations section, because I claim that if you have a TAM that does not have a TEE, then you have much more security risks than one that does. And so it does affect the security consideration section, certainly.
And if that
So I
is
was
running
trying
it,
to write the document to be agnostic.
no, but that needs to be secure, yes.
Yeah,
But
yeah.
should you discuss its password properties about reuse? Should you discuss how you patch that system? You know,
Right.
that's a bunch of system security issues there that have nothing to do with the protocol.
Yeah, yeah. I'm trying to write it such that if you have another implementer besides me that's implementing the TAM, and they're trying to do so with a TEE, then they're not confused when they see the term TEE,
I would
and they think it's their TEE and not the other
I
one.
would strongly suggest putting a separate informational document saying this is one way to implement a good TAM. And it's nothing to do with the actual protocol spec or
There's nothing
architecture spec.
normative in any spec, so why do you argue? I'm trying to figure out why you're arguing it should be a different spec
Because
as opposed to a
You have to create
conformity.
extra terminology to talk about if that is implemented using some similar building blocks, which might be a very good idea. I agree completely. But you're saying that I have to create a separate set of terminology off on the left to deal with the fact that I'm using similar components or the same components on the right, which is the same thing as saying, okay, do I need to describe, if this is talking to a web server for downloading images that happens to use a TAM, do I need to describe it as the third TAM? Sorry,
So
as the third TE, right?
Let me
they-
show you my later slides and see if you still have the same opinion. You might, right?
Because everything in the system might use a TE or multiple,
True,
right?
true,
So
true.
having separate names for all of them, just to be able to describe the part on the left seems confusing.
So can,
I understand your
you
point.
have 4 minutes left, so if we can just continue and then
Yeah.
if,
Okay.
Eric, if it's still not clear, then please,
Yeah, we can
Take it
discuss
to the mail.
afterwards, it's fine.
Yeah.
Okay. Thank you. Okay. Yep. You can skip that. I already said, yeah, the policy stuff, we didn't implement that yet. This was the slide that I showed before. So this is last IETF's slide. Okay. So I labeled it at 103. Changes from 00 to 01 in between last IETF and this IETF. The HTTP BIS working group has this document that's updating BCP 56, which is building protocols with HTTP. So it's intended for the rest of IETF. Anybody that wants to use HTTP as a transport should be paying attention to BCP 56, and they're updating it. And that's an active discussion there. And in fact, I think it was only like a 10-minute discussion on the agenda for this week, which means they're almost done with it. And so what happened is that I asked the authors of that, Mark Nottingham, to do a review of this document to say, hey, are we doing it right? And he came back and said, you're doing it almost right. With one change, he said, first of all, the document says to use a specific media type. And so he changed it to say OTRP plus JSON instead of application/JSON. The slide that I showed last IETF from Hackathon, we were just using application/JSON. It says use a specific media type as the recommendation. When he did his review, he said, the only thing that I see that should be done differently is instead of using a GET in the first message, so if you go back a slide, you see the very first message is a GET at the top there. Okay, go back. Thank you. He said you should be using a zero-length post instead of a GET. And then you're consistent. And we said done. So that was the main technical difference between 00 and 01. Now you can go on. Here's the same slide now updated. You can see at the top it says post instead of get, and instead of JSON it says OTRP plus JSON. That's the slide. Okay. Now the other thing that you'll see is in the top right. Okay. HTTPS server parentheses broker, whatever is the thing that's this vertical line here is what this spec does, and the vertical line to the far right is what the OTRP spec does. Okay. So there's an actor here that is a thing that's responding to HTTP and doing the encapsulation and adding the headers and so on. And I need a name for that piece, which is not a generic HTTPS server. It's the thing that sits on top of the HTTP protocol and adds the right headers and stuff. And so I needed a name for that anyway. Okay. So to respond to Eric, I needed to have some name for this, which is different from HTTPS server. If you went back to my 103 slide, it said HTTPS server, and that was kind of confusing because I'm not talking about the HTTP protocol implementation. So I invented a term, and I happen to use HTTP broker for symmetry. I'm not wedded to that. If you got a better suggestion, but I wanted to have some term we could agree on. But I'm willing to go along with whatever the working group tells me. I think that's my last slide. Is that right there, right?
So,
Yeah.
so you want to call it TAM broker?
That was my. I picked a name out of the air, and I picked that one for symmetry because on that slide you can see on the left, it's OTRP agent and agent broker are those two lines on the left. And so on the right, I had TAM and TAM broker just for symmetry. Okay, the architecture document right now has OTRP agent, an agent broker, and TAM, but I needed 2 terms over here just for symmetry, and so I picked TAM and TAM broker. Again, I'm not wedded to that. If the working group wants something else, that's fine with me. So my last question is on the last slide, which I will ask the chair since I'm not acting as chair for this part here. We have 2 independent implementations in progress, Ming and I, from 103 Hackathon and forward. And we think that this is the necessary for the working group. And so what's the next step?
Yeah. Well, I guess I need to ask first, does the group believe this is needed for Teep? So I guess I should ask, does anybody object or have reasons for why it doesn't belong in this group? This document. Okay. That being said, let me just get a show of hands. Has anybody looked and reviewed this document? Oh, there's actually a couple besides me.
4 here plus Ming.
Huh? Yeah.
Hands plus Ming.
Yeah. Okay. So does the working group believe we should be, and are we ready to adopt this document as a working group document? So, yeah. So let me ask, are there any objections? Since I think we'll have consensus. No objections? Okay. So I will take it and confirm it to the list. Okay.
And if people have opinions on terminology, happy to send that to you. Again, there's no answer that I'm wedded to. I just needed something. So, all right, thank you.
I'm sure you'll get feedback.
No problem.
Okay, so any other order of business? Since we're out of time, I'll give you 2 seconds. Going once, going twice? All right. Thank you, everyone. Okay, blue sheets, please. And thank you, Stephen, Jaime, and Ned. Did everybody sign? You can sign on. Pueden firmarlo otra vez, total.